Hello everyone, my name is Harshadikari and the topic for today's presentation is Mealy's model. First, to know what is a Mealy's model, we should know what a finite state machine. A finite state machine is a machine that has many states and has a logical way of changing from one state to the other on a guiding rules. There are two types of finite state machine, Mealy model and Murray model. But today we will be focusing on Mealy machine. A Mealy machine is an FSM whose output depends on the present state as well as the input. In Mealy machine, every transition for a particular input symbol has a fixed output. Mealy machine can be described by six tables where there are finite set of states, finite set of symbol called the input alphabet, finite set of symbol called output alphabet, input transition function, output transition function, and the initial state from where any input is processed. Here is a block diagram of Mealy machine. As you can see, the output Y is dependent on the present state as well as the input X. The flip-flop receives the input from the combination circuit and the first combination circuit receives the input from the flip-flop. Here is the state diagram for the Mealy machine implementation. There are three states 0, 0, 0, 1 and 1, 0. We filled up the truth table using the state diagram. The state diagram does not cover these values as it has only three states 0, 0, 0, 1 and 1, 0. Hence, the values concerning these them are considered as don't care. The rest of the truth table is filled using the state diagram, like current state being 0, 0 and input 1, input 0 gives us next state 0, 0 and output y. The flip-flop column is filled using the flip-flop table we have studied earlier, which can be seen as DA 0 and 0 gives us 0. 0, 0 gives 0, like 0, 1 gives us 1, and the rest as follows. Now, we fill up the K-maps for the D flip-flop input using the truth table from the previous slide. The K-map for the DA can be seen as follows. We fill up the main terms in the K-map 0, 0, 1, 0, 0, 1, don't care, don't care. These two form a pair and these two form a pair which gives us the expression as AI plus BI, which can be simplified as A plus BI. The K-map for DB can be seen as follows: 0, 1, 0, 0, 0, 0, don't care, don't care. In this K-map, there doesn't seem to be any pair, so the expression for DB is A bar dot B bar dot I. This is the circuit for the Mealy machine using a D flip-flop. Now you remember the expression DA was A plus B I, and the expression DB was A bar B bar I. Now here is A flip-flop and here is B flip-flop. Now as you can see, this gives us A and this gives A bar. This gives us B and this gives us B bar. Now here goes A to this OR gate and here goes B to this OR gate, which gives us A plus B as output. Now this output with the I input goes into the AND gate, which gives us the DA, A plus B I, and which is connected to the A flip-flop. Similarly, this A bar is connected to this AND gate, the B bar is connected to this AND gate, and I is connected to the AND gate which gives us output as dB A bar B bar I, which is the input for the flip-flop B. Now, these outputs are connected to an AND gate, which gives us output Y, which is the output. Mealy machines are widely used to check for pattern occurrences, so a simple example for it is as follows. Construct a Mealy machine that prints A whenever the sequence 0, 1 is encountered in any input binary string. Let A be sigma b 0, 1. Now, it wants there be any input binary string like 0, 1, 1, 0, 0, 1. Now it wants us to print A when there is 0, 1 in the encounter input binary string. 0 is not the desired input desired sequence, so we print any other thing other than A. Here we go with B. Let's print B. 1. Here we get 0, 1. So we print A. Then again 1. It is not the desired sequence, so we print B. 0. Again B. 0. Again B. Now here we again get 0, 1. So here we print A. Now there are three states. A be the initial state, B 0, and C 1. As from the initial state we move towards B, we get 0, which is now the desired sequence, so we print B. We move to the C. Now 0, 1 is the desired sequence, so we print A. Now as it is a Mealy machine, there is no final state. It moves back to A and B. Now it goes B. It is not the desired result, so we print B. Here again B. Here again B. And here also again B. There are many advantages and disadvantages of the Mealy machine. Some of them are as follows. Mealy leads to the reduction in number of states. Mealy is faster because output will change as soon as the input changes, but it leads to asynchronous outputs leading to instability. Mealy is complicated compared to Moore. For any asynchronously behaving circuit, will have some other applications of the Mealy machine are Mealy machines provide a rudimentary mathematical model for cipher machines. Considering the input and output alphabet, the Latin alphabet, then a Mealy machine can be designed that given a string of letters can process it into ciphered string. Moore Mealy machine are DFAs that have also output at any tick of the clock. Modern CPUs, computers, cell phones, digital clocks, and basic electronic devices machines have some kind of finite state machine to control it. By finding the intersection of two finite state machines, one can design in a very simple manner concurrent systems that exchange the messages. For example, a traffic light is a system that consists of multiple subsystems such as different traffic lights that work concurrently. Now, I would like to conclude this presentation by thanking you, and I hope I was able to present this topic clearly.